Number 1, write the prime factorization of each number in exponential notation. That means we can make a factor tree to start this problem. Since this is an even number, we can divide it by 2. 2 times 132 would be 164. Since 2 is prime, I can circle that. Now I have to break down 132. I'm going to divide it by 2 again. That gives us 66. Again, the 2 is prime, so I circle it. Now I'm going to break down 66. I could divide it by 2, or I could do 6 times 11. 11 is prime, so I circle it. And to get 6, it's 2 times 3. These are also prime numbers. Now I have to write my answer in exponential notation. So I have 3 2, so 2 to the third power, times 3 times 11. This is my final answer. We have the same directions for number 2. This time, if it ends in 5, I know that one of the factors is 5, so it's divisible by 5. So in my calculator, I'm going to do 4725 divided by 5. That's 945. The 5 is prime, so I circle it. Again, this ends in 5, so it's divisible by 5. 945 divided by 5 gives us 189. 5 is prime, so I circle it. 189. I can't divide it by 2 because it's not even, so I'm going to try 3. 189 divided by that gives us 63. 3 is prime, so I circle it. 63 I know is 9 times 7. The 7 is prime, so I circle it. And 9 is 3 times 3. So I've gotten this down to all of its prime numbers. Now I'm going to write the answer in exponential notation. I notice I have 3 3's, so 3 to the third power times 5 to the second power times 7. This is my final answer in exponential notation. The next section says expand and evaluate. So let's make sure we do both parts, expand and evaluate. Expanding is easy. That's just writing out what this means. This means there's 2 of them. And then evaluate is solve. So I can use my calculator to do negative 1.1 times negative 1.1. That gives me positive 121. So again, here, remember to expand and evaluate. For number 4, we do the same thing. Expand, so negative 2 fifths, 3 of those. I need 3 of those. So expanding looks like this. And then evaluating is not that hard with fractions. Just go across the numerator, negative 2 times negative 2 times negative 2. So 2 times 2 is 4, 4 times 2 is 8. That's going to give us negative 8. And then in the denominator, 5 times 5 times 5. That's 125. So for this one, expand and evaluate. Evaluate the expressions. So this is like an order of operations problem. I am noticing that I have all these groupings, like multiplication, then addition, then multiplication, then addition, then multiplication. So I can take this one step at a time. 8 times 10 to the 5th power, that would be an 8 with 5 zeros. Or you can punch that in the calculator, 8 times 10 to the 5th power. Okay, then 4 times 10 to the 1st power. That's going to be 4 times 10, which is 40. And then 9 times 10 to the negative 1st power. We learned that negative exponents are fractions, so that's 1 over 10, so this is 9 over 10, 9/10. And then your final step would be just add that all together. So by adding that all together, I get 800,040 and 9/10. And you can express that with a fraction or a decimal. Okay, we're going to simplify our exponents. I see here it's a multiplication problem, and we have coefficients. So I'm going to do my coefficients first. That's 14 times 3, and that equals 42. Then I see we have like bases, x's, and it's a multiplication problem. When the bases are the same and we're multiplying, we keep the base and we add the exponents. So we have to add -3 plus 6, and that gives us 3. And then on to the y's. When the bases are the same and we're multiplying, we keep the base and we add the exponents. Final answer is right there, 42, x to the 3rd, y to the 9th. Okay, now we have a division problem, so this will be the quotient of powers. So first we have our coefficients. So we do regular math with those. That's 63 divided by 7, which is 9. And then we have like bases. When the bases are the same and we're dividing, we keep the base and we subtract the exponents. But be careful here, it's 8 minus a -4. So our exponent is going to be 12. And then like bases again, when the bases are the same and we're dividing, we keep the base and we subtract the exponents. There's an invisible exponent with a 1 there, so it's 1 minus 5, which is -4. Okay, then this would be our first step. But then we have a negative exponent right here. To express a negative exponent as a positive exponent, we turn it into a fraction. So our most official answer would be keeping 90 to the 12th, but then moving e to the 4th power into the denominator to make that negative exponent become a positive. So this would be our very best answer. Okay, solve for x, and we know that x to the 2nd power is 64, and x to the 2nd power is 144. So to do this, we're going to take the square root. 8 times 8 is 64, and 12 times 12 is 144. The opposite of squaring a number is taking the square root. Then for number 9, this is what to the 3rd power is 64. So over here we're going to do the cubed root of 64. That would be 4, and the cubed root of 729 would be 9. So just as a reminder, to get a square root on a calculator, we do second function x squared. To get the cubed root on a calculator, we put in 3 second function and then the caret key and the number.